Somewhere in a warehouse, a robot picks up a box it's never seen before, folds it along seams it wasn't trained on, gets bumped mid-fold, and adjusts. Finishes the job, moves to the next one. 99 times out of 100, it gets that right. This is not a demo, that's in the production, and it was reported on yesterday, the same day that a former rival trio decided they needed each other more than they needed to win. And the same day that a sovereign military from another country published satellite coordinates of an AI data center and promised to erase it as part of escalating threats in the Iran conflict. And the same day, someone figured out how to make a computer ship survive temperatures hotter than lava. So let's get into it. Generalist, a robotics company that many people may not have heard of, released Gen 1 yesterday. And I think this one is really important because we've had robots in factories for decades, yes, and they're incredible at doing one thing 10,000 million times. Welding a car door, placing a chip on a circuit board, but they're brittle. You move the car door just 2 inches to the left and the robot welds air. Gen 1 is different. It's a single model that folds boxes, packs phones, services robot vacuums, and sorts auto parts. And this is not four different systems doing those four different things. This is one system, and it does all of these at 99% success rates and roughly 3 times faster than its predecessor. But the detail that really stopped me is this. When researchers disrupted the system mid-task, knocked it out of place, knocked something it was working on out of place, introduced an object it had never encountered, the system improvised. It pulled from patterns learned in completely different contexts to solve the new problem. So this isn't just following some script. This is something closer to thinking on your feet. Now, how did they build this? With something called data hands. These are wearable pincers that humans strap on while doing physical tasks. So they fold laundry, they sort parts, pack boxes. The devices capture every micro movement of the hands, every grip adjustment, every fingertip correction, over 500,000 hours of this data. No robot teleoperation, just humans doing human things, wearing gloves that help them remember everything. So here's why this lands differently from every other robotics demo that you've scrolled past recently. A robot that can do one thing at 99% reliability is the same tool that we've had for a while, but a robot that can do dozens of things at 99% reliability and learn the next thing in about an hour of calibration, that's a workforce. That distinction changes the math completely. You don't need a different robot for each task in a warehouse. You need one system and an hour to teach it the new skill. That's the gap between, oh, this is an interesting technology, and this changes how every fulfillment center, every factory floor, and every logistics hub on the planet operates. Yesterday, that particular gap got a lot smaller. Are we here yet? Maybe not, but we're closer. This connects to something that the Century Report has really been tracking closely. You'll remember that yesterday we reported that Japan's Ministry of Economy formalized a plan to make 30% of the global physical AI market by 2040 be based in Japan. And this was driven by a workforce shrinking by 15 million people due to aging. Back on April 1st, MIT Technology Review documented gig workers in both Nigeria and India and other places recording household chores to generate training data for robots. This data pipeline that we're talking about here, humans wearing sensors, generating movement libraries, and the deployment capability, this is converging. Gen 1 is evidence that the convergence isn't theoretical anymore. This is a shipping product that's happening right now. All right, let's shift away. 3 rivals, 1 room. From physical AI, we were just talking about, to something I genuinely didn't expect to come this quickly. OpenAI, Anthropic, and Google, 3 different companies that compete on everything, are now sharing intelligence with each other. Through something called the Frontier Model Forum, they've begun pooling data detection to identify and counter Chinese labs systematically that are extracting capabilities from their AI systems, or so they accuse, with a technique called adversarial distillation. It works like this. You make thousands of carefully designed API calls to a frontier model. You collect those outputs, and then you use those outputs to train a cheaper model that mimics the frontier system's capabilities without ever having to access its architecture or its training data. So it's less like stealing somebody's recipe and more like hiring the chef to cook 1,000 dishes, filming every one of them, and then teaching someone else to replicate that. So the Frontier Model Forum was founded in 2023 by these three companies and Microsoft. It existed as a kind of shared research body, but coordinating on detection, which is what they're doing now. So actively sharing signals about who's probing their systems, how, and at what scale. This is a different kind of cooperation entirely. This is competitors building essentially a shared immune system. The Century Report first documented this problem back in February, when Anthropic publicly accused Chinese labs of mining Claude's capabilities. At the time, it was a bilateral complaint, one company with one accusation. But yesterday's announcement represents the structural response, the conclusion that no single provider can see enough of the attack surface alone. You need the pattern across all three to understand what's really happening. So here's what makes this genuinely novel. Chip export controls restrict hardware access. Distillation detection restricts capability access. And what's forming is a two-front architecture, one physical and one informational, around frontier AI. Whether it holds depends on whether detection can evolve as fast as the extraction methods. But the fact that these three companies looked at a competitive landscape and decided that collective defense matters more than individual advantage on this dimension, that's a signal, I think, about what kind of era we're entering here, where collaboration is required just to survive. Not one where the biggest player wins by hoarding, but where shared infrastructure outlasts captured position. And while it may be a small step in that direction, especially considering this is companies we're talking about, extractionist by nature, this is hopefully a step toward the ultimate collaboration that will eventually minimize the need for those type of companies in the first place. Now, I need to take you somewhere darker for the next story here, because while those three companies were coordinating to protect their digital capabilities, the physical infrastructure underneath those capabilities came under explicit military threat. And this isn't even the latest in the series of escalating threats between the Trump administration and Iran. This happened yesterday. Another threat was made this morning. But yesterday, Iran's Islamic Revolutionary Guard Corps published a video showing satellite imagery of OpenAI's Stargate data center in Abu Dhabi, the $30 billion facility. This is 16 gigawatts of planned compute capacity, a joint venture with SoftBank and Oracle. And the IRGC's message was, essentially, we know exactly where this is, and we can destroy it. Now, this isn't an abstract, empty threat. Iranian missiles have already struck AWS data centers in Bahrain and an Oracle facility in Dubai in recent weeks. So the Strait of Hormuz remains closed as of right now. The escalation is ongoing, and the IRGC video framed AI data centers as equivalent retaliatory targets. If you threaten our civilian infrastructure, we target yours. That's essentially the message. I want you to let this sink in for a second. The most powerful AI systems in the world run on physical machines in physical buildings that need physical power and physical cooling. So we talk about AI like it lives in the cloud. We've talked about the cloud like it lives in the cloud. It never has. Like it's this weightless abstract layer, but clouds are made of warehouses, and warehouses have GPS coordinates. The intelligence era's entire capability stack depends on enormous, immovable, power-hungry facilities concentrated in a handful of locations chosen for cheap energy and friendly regulation. Those same locations are now demonstrably within range of cruise missiles. That's not a hypothetical risk assessment. That is a video with satellite imagery and an explicit promise. The geography of AI compute was chosen for economics, and it's now being stress tested by geopolitics. And domestically, the friction here in America is different, but it's still rhyming. Yesterday, Port Washington, Wisconsin became the first community in 2026 to put a data center project to a public vote, a referendum on a $15 billion Vantage facility called Lighthouse. At least 4 more community ballot measures on data centers are scheduled this year. The Michigan City contamination case we covered back on March 30th, where residents forced a construction halt after finding arsenic and TCE in the soil at a suspected Google site, that was an earlier signal. This Port Washington one is the next stage. Opposition that's not just protest, but democracy, ballot box politics. Iran's threats and Wisconsin's ballots are categorically different, obviously, but they share a recognition that the physical infrastructure of AI is not a neutral backdrop. It's a site of contestation, military in one case, democratic in the other. Both constrained where and how fast the substrate of the intelligence era gets built. And both reveal that the people living near these facilities, whether in Abu Dhabi or Wisconsin, are impacted by what's being built in their backyard. All right, let's shift to another story here, from vulnerability to seeming indestructibility. Something might reshape what infrastructure even looks like here, because a team at USC just published in Science about a chip that survives conditions that no chip has any business surviving. The device is a memristor, which is a type of electronic component that stores and processes information simultaneously. And this particular memristor operates at 700 degrees Celsius, which is hotter than the surface temperature of Venus, hotter than molten lava. It endured over 1 billion switching cycles at those temperatures, and it runs at 1.5 volts with nanosecond speed switching. So the trick is materials science. The device uses tungsten electrodes with a graphene bottom layer and a hafnium oxide ceramic in between. So at extreme heat, tungsten atoms try to migrate through the ceramic, which is what normally destroys electronics at high temperatures. But tungsten atoms can't bond to graphene. So the researchers describe the interaction like oil and water. The atoms drift away instead of forming the conductive bridges that would cause the failure. And they discovered this accidentally, by the way, while trying to build something else entirely. Now, why should you care about a chip that works in conditions that you'll never experience? Well, two reasons. First, memristors perform matrix multiplication, which is the mathematical operation behind over 92% of the computation in systems like ChatGPT, through physics. Current flows through the device. Ohm's law produces the result. No step-by-step digital calculation is required. So at a moment when data center energy consumption is a binding constraint on AI scaling, a computing architecture that gets answers through the physics of current flow, rather than billions of sequential operations, opens a path to efficiency gains that are not incremental, they're structural. Second, and this is the one I think is genuinely exciting. Heat tolerance means density. The reason data centers need so much cooling infrastructure is that the chips fail when they get too hot. Chips that thrive at extreme temperatures can be packed tighter, run harder, need less cooling. The energy cost of keeping infrastructure from melting is a meaningful fraction of total data center power consumption. A computing substrate that laughs at 700 degrees changes that equation from the atomic level up. And this joins a thread that the Century Report has tracked through the AI chips on non-silicon substrates arc. The memristor here adds something new, not just a different material, but a different relationship between computation and physics. The chip doesn't calculate the answer. It is the answer expressed as current. All right, one more story today, and it's the most complicated one, I think, to hold in your head of what we've covered, and we've already covered a lot. Yesterday, OpenAI, the company worth $852 billion currently, the company whose Stargate facility is being threatened by Iran, and the company whose products are driving the economic restructuring that everyone's worried about, published a 13-page policy paper proposing how to manage the world its technology is creating. The proposals: public wealth funds that give every citizen a stake in AI-driven growth, robot taxes that shift the tax burden from human labor to capital, portable worker benefits that follow you between jobs, and a 4-day work week. Now, none of these ideas are new individually. Ireland made a basic income for artists permanent. David Shapiro published 8 building blocks to universal high income. Peter Diamandis mapped a UBI to UHI transition. And these are just people that I follow. The Century Report has tracked all of these through the Universal Basic Income and Labor Floor Policy arc. What's new, though, is who's saying it. When the most valuable private AI company on Earth publicly advocates for taxing robots and shortening the work week, the conversation shifts from interesting think tank proposal to the people building the disruption are telling you it's coming, and here's what they think the response should look like. But, and this is really important, the paper arrived the same day as a New Yorker investigation raising serious questions about CEO Sam Altman's trustworthiness, drawing on over 100 sources. And policy experts, quoted in Fortune, described the proposals as agenda setting rather than actionable. So no binding commitments, no implementation mechanisms, and no timeline. So there's a structural tension here, and I don't want to smooth that over. The entity most responsible for the economic disruption is proposing the solution to that disruption. And this doesn't make the proposal wrong per se. A 4-day work week and a public wealth funds, these are worth debating regardless of who proposes them. But it does mean the conversation can't end with OpenAI. The framework for distributing AI-generated prosperity needs to be built by institution with democratic legitimacy or something new, not adopted wholesale from the company whose products created the need. OpenAI opened the door. Who walks through it and what they build on the other side, that's the real story, and it cannot be up to the same people. All right, 2 quick things from the release tracker. Google dropped an app called Edge Eloquent on iOS. This is a free dictation tool that runs entirely on your phone using Gemma-based models. So no internet is required, no subscription. It transcribes speech in real time, and it strips filler words automatically, and it can reformat your text into formal, short, long, or key points styles, all on device. This is frontier quality speech recognition running locally for free with your data never leaving your pocket. And Freestyle launched a cloud sandbox platform designed specifically for AI coding agents, secure execution environments where autonomous code writing systems can run without touching your production infrastructure to practice, essentially. So given what we've been covering about agent pricing and security, dedicated sandboxes for agents feels very timely. All right, here's what I want you to hold today. Yesterday, there was reporting about a robot improvising its way through tasks it had never seen. Also, 3 rivals decided that their shared vulnerability mattered more than their individual advantage. A military published the GPS coordinates of the building where the future is being computed, or at least one of them. A chip survived temperatures that would melt the floor of a steel foundry. And the company most responsible for reshaping the economy published its proposal for how to hold the economy together. Every one of those is a story about the same fault line, the distance between what we're building and how fast we can protect it. And that capability is accelerating. The physical infrastructure is exposed. The governance is being drafted right now by the very organizations whose products demand it. And very soon, watch for whether other frontier labs join the distillation detection coalition, because if Microsoft comes in, the architecture becomes industry-wide. Watch for more community data center votes as well, because Port Washington is the first of at least 5 this year, and the outcomes will shape where AI infrastructure can physically exist in America. And watch for the memristor, because if computation through physics scales the way early results suggest, the entire energy conversation around AI shifts from how do we power all these chips to what if the chips barely need power at all. We'll see you tomorrow.